Good afternoon. Welcome, everybody. I'm Fernando Gamero. I'm a senior solutions architect in AWS, and I'm in the telco industry.
I'm Craig Allen, and I'm chief architect at Verizon Connect.
So in today's breakout session, we want to bring you in a journey through the transformation of Verizon Connect. So the idea of today's session is to give you a deep dive on the why, when, what, and how Verizon Connect tackled the challenges that they face when they were really slowing down in the pace of innovation, and how they were delivering new features for their customers, and how they seized that opportunity to transform their business and remove those roadblocks that they were facing. So the journey will begin where they realized that those challenges that they were facing were really impacting the way they were able to deliver for their customers the new features. And when they started back in 2015, they were only able to release a single feature or a single release every quarter. Furthermore, they were basing their application in a monolith, which made them very slow to react to change. Initially, they were running their application in their own data center, and throughout the different years, they moved into a more hybrid architecture, but that also posed some challenges, and we'll see those coming throughout that journey. Their real goals were to be able to accelerate, create a different pace of innovation, and start breaking down that monolith. But because the different architectural decisions that they were making, they started looking at what challenges they face in terms of connectivity, what other challenges they face in terms of keeping the data in sync across this hybrid architecture. And they started to gather on these lessons, and they learned through those mistakes. At some point in time in their journey, they decided we need to do something radical. So they look into migrating all into AWS. So they partnered with AWS through the Experience-Based Acceleration Program, and we brought the expertise to help them to do that in migration. Now the journey, they were fully successfully migrated into AWS, but the journey didn't end there. They were initially moving into, you'll see when Craig speaks about this, that they were looking about lift and shifting, but they wanted to start optimizing these platforms, start realizing the potential of the cloud by using more managed services. And they did this through different things that they were implementing throughout the journey and also after, through pipeline integrations, CI/CD, automation. And these helped them to increase the number of releases tenfold. But again, the journey doesn't end there. Craig is going to give you a good peek on what the future holds for Verizon Connect and how they are now looking into take advantage of the cloud, now that they are all in, take advantage of cloud-native services and doing design for cloud-native. They are also going to start looking more and more of following event-driven architectures and those patterns to ensure that whenever a new microservice is designed, is fit for purpose, is scalable, serverless. They're also going to start looking at leveraging more purpose-built data stores. In the past, you'll see that they focus primarily on relational databases, and now the idea is to start taking advantage of other data stores that are potentially more suitable. Now, throughout that journey, Verizon Connect has partnered with AWS to help with the acceleration into the cloud, the migration into the cloud. But now that this is happening, we are a good partner of Verizon Connect in terms of how we accelerate the adoption of new technologies, upskill their workforce, bring in new services. Whenever there is a new announcement, we're trying to see if that's a suitable fit for Verizon Connect, and then we'll bring that on board. And that partnership is also going to help us accelerate the development of new device ecosystem for their IoT ecosystem of devices and taking advantage of native AWS services like IoT Core, IoT Shadow, IoT Jobs, and also helping them to push the processing of the data or processing of the events at the edge where that's possible. For example, Verizon Connect, Craig will explain this in more detail, has the capability to process video on the vehicles, but the idea is to be able to process machine learning algorithms and machine learning models on the vehicles so that inference can be done remotely. So all this combined has, and throughout the journey of the years, has enabled Verizon Connect not just to modernize their platforms, but also release new features at a much faster pace to their customers. But it's also a quite important point that this transformation is not just purely technology transformation, it's also workforce transformation. Their workforce has become more agile, more, let's say, more interested into technology, into learning new things from technology, and ultimately really focus on what matters to their business and how to keep on experimenting and improving. So without further ado, I'll let you take Craig through this fantastic journey.
Thank you very much, Fernando, for that warm introduction. Before I carry on too far into the journey, I'd like to take a quick opportunity to give a brief introduction to what we do. Verizon Connect is a leading provider of mobile workforce solutions. Our goal is to make customers more efficient while also keeping drivers safe on the road. We bring together the power of SaaS and IoT to track vehicles and driver behavior in order to create actionable insights for our customers to run their businesses efficiently. At the center of our journey is our flagship and award-winning product, Reveal. Device tracking is at the core of Reveal, which also has a suite of features that provide insights into drivers, vehicles, and assets. Reveal provides vehicle and driver safety through our dashcams and harsh driving events, Reveal Video, and also intelligent scheduling for your field engineers via Reveal Field. But taking a step back in time, the history of all of this journey dates back to 2015. Back when we were a well-known fleet tracking company called Fleetmatics, we were in a growth phase of our company, and we had made a number of acquisitions which were in various stages of their own journeys to the cloud. The accumulation of those products brought features into our flagship platform, but they also brought their own set of problems that needed to be addressed along the way. But in 2016, Verizon purchased both Fleetmatics and one of our largest competitors, Telogis, and brought us all together now under what is now Verizon Connect. And setting the scene at 2015 from an engineering perspective, our stack was entirely .NET. It was a set of monolithic applications with custom RPC code to communicate between services, in-process caching, hosted on top of Windows Server, and our primary data store was Microsoft SQL Server. Our build pipeline was running at 100 commits a day with an average feedback loop of about 30 minutes. Imagine that. 30 minutes from the time you commit code to the time our developers got feedback as to whether they passed or failed. And on top of that, we were only able to run one integration test a day across that entire stack. As you can imagine, this was a roadblock for us. And set the scene then for our releases. So we were only able to get 94 deploys a quarter out to production at a success rate of roughly 55%. Some of that attributed to the single integration tests, others because we could only deploy to our test environment every 2 weeks. But what that ultimately boiled down to was 4 value releases for our customers a year. On top of all of this, a big part of what I spoke about in the acquisitions was actually the accumulation of data centers and office labs behind the scenes. Over the years, we had grew to 9 physical data centers and 3 office labs, running hundreds of servers, hundreds of physical servers, and thousands of virtual machines. We were not staffed to maintain this infrastructure without the necessary expansion, and without the necessary expansion of our operations teams, we were maintaining these sites as economically as we could. But our challenge was focused more on trying to be competitive in the market and being able to drive value to our customers and delivering more products and features at a rapid pace, driving innovation. And in order to do that, we needed to deploy new technologies and adapt and deliver that on top of our data center infrastructure. But delivering and installing that new technology meant training up our staff and having to figure out how to run it and develop on top of it, which led to code quality issues when we actually released software on top of it. And to bring that all together, we were also running this at a fast pace, so we weren't doing this in an automated pipeline. We were manually delivering all of these services. And therefore, we were continuously in this vicious cycle of delivering more and more tech debt on top of the platform while trying to get ahead of the market. This was ultimately the root of all of our issues, and we needed to do something to change that. So we started our journey by first trying to tackle what we had. We needed to expand our engineering organization. We knew the only way to expand our engineering teams was to start decomposing our monolithic application and investing in developing more microservices. So in 2015, still in the data center, we approached breaking down our .NET monolith into microservices. And we took the opportunity to start removing the custom RPC code that we had and moving towards WCF, and to implement more standard caching platforms like Redis and Memcache instead of the in-process caching, while also allowing us to start delivering more event-driven architectures using RabbitMQ. However, as we got into this, we ran into challenges. We weren't set up to deliver these services on our infrastructure, and we didn't have enough expertise to set these services up as foundational infrastructure for our microservices. And we ran into a number of issues when delivering services on top of them again. But we also didn't know how to deliver microservices at scale. We were used to monolithic applications. We knew how to deliver services that were static and deployed for peak load. We hadn't invested enough time in scaling architectures with lots of load balancers in behind it. We also needed to go and upskill our development teams to understand how to monitor and triage issues going across multiple services, how to track transactions across different components. So we invested in bringing in a third-party vendor to install new monitoring systems so we could get full end-to-end visibility. But the biggest piece was config inconsistencies. We still hadn't learned. We were still deploying manually, and we still weren't automating the delivery of these services. So when we delivered our first set of microservices, we spent 2 weeks in a war room trying to figure out what we had done wrong. The custom RPC code wasn't documented, and we needed to reverse engineer the RPC code in order to deliver the microservices. But the performance that we had expected from the microservices, we weren't able to achieve it in performance or in production. What it transpired to was there was an inconsistency between our environments. Our performance environments, our servers were set to maximum power. But in production, they were set to power efficiency. So the CPUs were stepped down. And so all of this led to us deciding we shouldn't be in this business. We are here to solve customer problems, not build infrastructure and plumbing. So we decided that we needed to go and look at a cloud provider to do this for us. And so in 2016, as part of our architecture, we wanted to go and rewrite our data ingress layer. We took that as an experiment to go out to AWS and redeploy or rewrite our architecture to sit on top of the cloud. But we wanted to be a cloud agnostic. We weren't sure of whether AWS was the right move for us. And we wanted to take whatever we'd done and move it into another cloud if we needed to. So we kept it fully cloud agnostic. There were, again, some challenges as we deployed it. There were missing services. Our ingress layer depended on protocol-level load balancing, the likes of UDP and TCP. But at the time, there was no UDP load balancing. We built our own UDP load balancing in AWS on top of a VPC in order to allow this to work. Something we regret at this point, and I would not advise anybody to do themselves. And we ultimately transitioned to UDP load balancing when it released in AWS. But we weren't experienced to manage it. It was expensive. There was zero benefit in terms of cost in delivering it in AWS versus the data center because we were still managing the EC2 instances underneath. We were still running Rabbit, and we were still running Windows with .NET applications. But we had to take the additional hit of upskilling our teams. We now had to manage services in AWS, which now could only be monitored through CloudWatch, which we then needed to integrate with our internal monitoring system. So we had to train them, and we also had to teach them to treat services like cattle, not pets. But ultimately, in 2016, we were able to deliver a new device gateway, which was able to cater for all of our traffic loads. And we slowly, over the last few years, have migrated and used this as a foundation to bring all our device traffic through into our platform. But we'd made mistakes along the way, and we realized if we're going to continue success on AWS, we needed to go back and look at our patterns and practices. We needed to figure out how do we do this at a scale and utilize all of our engineering teams. So we developed standard patterns and practices around delivering software on top of AWS. And we also went back and decided to look more into managed services. We needed to stop doing infrastructure ourselves, and we needed to take advantage of the services that AWS provided and the expertise that AWS support can bring to delivering that, while also providing a piecemeal migration to take that monolithic application and break it up into microservices and ultimately deliver that on top of AWS. Obviously, there was a handful of challenges there too. The first thing we noticed is when we got into the depths of the RPCs and the in-process caching, we found out that we were doing broadcast between services in order to keep caches up to date. And so, obviously, within the VPCs, you can't do broadcasting. So we had to go and start removing that before we could start the migration to microservices. So we worked towards that. We invested heavily in revamping our CI/CD pipeline and making sure that everything that went into AWS was automated. We also had to go back to our teams and re-educate them about how to develop software. We had spent years developing things for the data center, and everything was developed based on peak traffic load. And so instead, we needed to make sure they were measuring their services and instrumenting correctly, and looking for a metric that ultimately indicated throughput and scale and requirement for the service, which allowed us to then scale it automatically based on load. And lastly, and this is a topic that I keep dropping because it's very easy to change technology. It's difficult to change people and process. And so we focused a lot over the years on culture and ownership and bringing everybody up to speed with how AWS operates, how to get the best from it, but also putting autonomy back on the teams to go and deliver their software on top of it. So in 2017, we delivered a new CI/CD pipeline from scratch with the capability of delivering feedback to the engineers within less than a minute rather than the 30 minutes you saw before. And we delivered a framework around ownership that divvied out the different ownerships across the different teams and the autonomy for them to make changes themselves. And this set us up then to go and continue with the piecemeal migration and start delivering it at a rapid pace. So while in the background, we were breaking up the monolith, we were putting more microservices in AWS, we had an opportunity to start looking and investing in our first cloud-native product. We had this idea around video or a dash cam that we wanted to put into the Reveal product. And it was an opportunity for us to go fully cloud-native and look, and test our hypothesis without having to fully invest in the product. But by going fully cloud native and using full advantage of AWS, we were able to bring in AI as part of the first offering. If we had done that in the data center, we would never have got to the product that we released. But in all things, there was still, again, a few hurdles that we had to jump to get this out the door. The first of which is we still had a large part of the Reveal platform in the data center. And you have this brand new product that is being set up fully cloud native, and figuring out how to integrate the two and communicate and all of the security around that, because we have one that's fully dependent on Active Directory and another that is dependent now on IAM roles, and having to figure out how to get them aligned. We had to very rapidly get service governance around the new service offerings that we wanted to use in video, the likes of SageMaker, and how do we get developers access, and how do we do data sovereignty, and how do we make sure that only certain data can be accessed for data models, and obviously the privacy around video files. How do we manage all of that? Service limits was an interesting one, a hurdle that we hit along the way, where everyone assumes that you can deploy into AWS directly and have a production-worthy instance set up. There are limits in your account, and it caught us off guard in certain specialist instances like a G3 instance where the maximum was 3. And so working with the account team before we went live would have solved an awful lot of problems. And lastly, again, is training and monitoring. We're fully cloud native. It was brand new space for a lot of our support and operations team. So we didn't want them logging into services. We had to look at how they got access and triage issues in production without granting them full access to remote onto anything. There was nothing to remote on in some cases. We were using serverless in that case. So they had to retrain on how to look for issues, how to solve them, and how to make changes without changing things directly in production all the way through. And we had to look at our monitoring and work with our vendors to make sure that our monitoring tools could be integrated with fully serverless products and be able to get that information back. But the outcome in 2019 was one of the fastest growing products to date in Verizon Connect. We released Reveal Video, and it has been growing ever since. It is now using Lambdas, step functions, SageMaker, OpenSearch as its core services to function. And it's been a huge success story. Now, going back to the previous story around migrating that monolithic application into microservices, at the end of 2019, we were roughly at about 1,000 microservices, roughly about halfway through decomposing our monolith. And we'd hit a roadblock. We had still had all of our databases sitting in the data center. We were heavily dependent on a direct connect between the data center and our AWS region. And we had a latency of roughly about 70 milliseconds. So at this point, we were starting to make concessions in our architecture in order to support services, in order to support building more on top of it and migrating up into AWS. We labored this decision for the next year, but in 2020, we decided to take a leap of faith and lift and rehost everything that was left in the data center and bring it up into AWS. So in 2020, in the middle of a pandemic, we decided that we needed to start planning to migrate all of our services. We've never done something this large. We had never coordinated a project across all of our 600 staff. And so we engaged with the experience-based acceleration team in AWS. And we sat down and we talked through what we wanted to do. And they took a cross-section of our team and spent 3 days discussing all of the services and working with them to essentially to give them a goal that they were going to deploy all of their services in AWS for the first time within the first 3 days. And at the time, they all thought this was impossible. In 3 days, we were able to do it. We got a first working deployment in AWS of everything that was in the data center up and running. And that was through the help and support of the EBA team. They helped us figure out an asset inventory of everything that we had in the data center and the gaps that may occur between what we were running and what was available in AWS at the time. But key to delivering this was making sure we could minimize customer interruption. The platform is 24/7, so we needed to make sure there was a minimal window for this migration. Through trial and error and through dry runs and failovers and failbacks, we eventually shrunk the amount of time it took to migrate all of the platform up into AWS. The last piece is data synchronization. Like I said, the majority of our data was still in the data center. So we worked very closely with AWS to build a solution out around DMS, to replicate all of that data into AWS, but also keep it in sync with the data center. We needed the capability to roll back if things didn't work out. But by 2021, in Q1, we took the smaller of the two platforms and went ahead and migrated it to AWS and completed it successfully in the first quarter. Minimal fanfare, but minimal issues. But we took the learnings from that to be confident in our US platform delivery, and we were able to deliver that by the end of the year last year, and we are now entirely in AWS for the Reveal platform. But what that took in numbers was we ran 50,000 automated tests to validate that deployment. We deployed over 10,000 applications across the different sites and environments. We had to migrate over 370 terabytes. We had to spin up 3,800 EC2 instances to run all of the applications. We had 760 database schemas migrated, and ultimately led to 470 servers being shut down in our data centers. These are huge numbers, and it was not taken lightly. But what's next? Well, now that everything is in the cloud, we want to take full advantage of that. Like I said, we had lifted and shifted our services from the data center, but we hadn't broken them down yet. We still had half of the platform to go. But we now have opportunities because we're fully in the cloud. We can go and reimagine some of these as we go along. So our current setup was we have EC2 instances running our .NET applications. We have our Microsoft SQL servers running on EC2 instances. And the piece I hadn't talked about yet, that we build our own internal hardware and firmware. Now we have the opportunity to go and look at, well, what can we do with our firmware? So the first stage is to look at how do we rehost this in a very quick manner to remove the infrastructure piece. So our first phase is to look at taking those applications and deploying them as containers and moving them into the likes of Fargate, or where possible, move them into functions and start leveraging more Lambdas. On the database side, we're starting to migrate more into RDS and remove the management piece. And on the firmware side, we're going to start venturing into AWS IoT Core and to remove the connectivity layer that we've been managing ourselves for years. But long term, we want to re-architect our platform. We continually re-architect and modernize the platform over time. And so the first step around modernizing our applications will be to look at managed event-driven architectures, moving fully into serverless architectures using step functions and Lambdas and Fargate. And on the database side, we're going to look more at purpose-built data stores, like TimeStream or Neptune, where it makes more sense for that data to live rather than a standard relational data store. And on the hardware side, we're going to have a look at Greengrass and use that as a base platform rather than running our own firmware, and focus solely on business logic on top that solves customer problems in the hardware. Our journey so far has led us to using multiple services across the AWS ecosystem. But we still have 1.7 petabytes of provisioned EBS storage today, hosting the majority of our data stores. We have 16 terabytes transitioned to RDS services, and we have 58 terabytes migrated to Redshift. So as you can see, we still have a huge opportunity to migrate more into AWS services. On the application side, we're running over 5,000 EC2 instances. We've started to transition towards more containers running 100+ ECS clusters, and we've been re-architecting the platforms or the products to use Lambda functions, and we've got over 10,000 Lambda functions running so far. Now, how has all this transformed Verizon Connect as a business? Well, at the beginning, I spoke to you about the 94 releases per quarter. So by 2018, when we released the CI/CD pipeline, we were roughly up at around the 500 releases per quarter. But by delivering the CI/CD pipeline, we were able to open the tap and allow our teams to be autonomous and be able to deliver their own parts of the product in an automated and consistent and quality-controlled manner. And there was an exponential growth in the amount of releases we could do. So over the course of the next 2 years, we were able to break up the monolith, turn it into microservices, put it on the new pipeline, and deliver that up into AWS. In the meantime, we were able to release new products and features fully cloud native, like video. And so by the end of 2019, we were up in the 3,000 mark per quarter. But obviously, we hit the roadblock, and we stagnated for a couple of months while we tried to figure out what we were doing. But in the middle of 2021, we paused and froze all releases for 2 quarters while we went through our migration of our EU and US platform at the end of 21, which has now set us up for our largest quarter yet at over 3,400 deployments per quarter, giving us a 33 times improvement in throughputs since we started this journey. How has this helped our workforce? Well, the first thing is training. We've done an awful lot about training, and I know I've been on and on about training and all of the challenges that we've had. But we've worked very closely with AWS to bring things like game days. We ran a game day this year across all 3 of our core sites in Dublin, Florence, and in New Zealand. And we intend to run more over the next couple of years to really engage teams and let them have exposure to services they wouldn't ordinarily get a chance to touch. We bring AWS in to run immersion days on new services that we want to run to make sure teams are comfortable with them before we go live in production. and get the opportunity to ask questions and learn about them. We work very closely with AWS to run POCs and demos when we're trialing our hypothesis around how we would approach something. We ask them about the services we think we want to use, and they will run POCs with us and validate our thoughts. It's allowed us to adopt new tech. Like I said, we've brought in AI into many more parts of our platform. But we've also introduced the what's new idea in Verizon Connect, and we bring our solution architect in once a month to run through all the changes in AWS. So everyone gets to hear about them and ask questions. It gives them some ideas around what they could use them for. We've brought in much, much more automation. Over the course of the last 7 years, we have automated just about everything that we do to deploy to get consistency and code quality. But we've also developed a lot more self-service internally to make sure that tools or everything that is deployed or requested is done in an automated fashion and simplify the process for developers and to remove dependencies on key roles like operations or our build engineers. A big area for us is actually chaos engineering that has cropped up over time. Here you see what we have internally as Manic Baboon and Resilient Rhino. They actually started out as scripts. Part of the device ingestion platform, we ran into issues. We started using Apache NiFi across multiple AZs. And invariably, every week, we would have an issue where they would get out of sync. And the only way to solve it was to restart the instance. So the foundation to Manic Baboon was to restart or to shut down an instance. And the foundation for Resilient Rhino was to pick up and detect these failures and restart the instance. And so we had these running on a daily basis to restart the instance, and we never had an issue since. But we've taken them as the foundation for our infrastructure resiliency, and we've added more capabilities over the last few years. Things around ECS clusters and Lambdas and making sure we inject failures and test them before they go live. But we're also looking at adding experimentation into our CI/CD pipeline to allow developers to write them and test things before we deploy anything. We've partnered with the AWS account team very closely over the last couple of years. We bring them in as part of our road mapping exercise so they understand what we're trying to achieve. And they look for opportunities for AWS to help us accelerate that delivery wherever possible and allow us to get to market as quickly as possible. And lastly is cost. When you're in the data center, you don't think about cost. There's always the upfront capital cost of delivering hardware into the data center, but nobody talks about how much it's actually costing you to run an application in the data center. Now that we're fully in AWS, we're driving KPIs and teams to make sure they understand what it costs to run that service. And it's imperative that they go and drive cost reductions themselves. From a customer perspective, I've already talked about Reveal Video and the foundation that was set up in 2019 with the first release. But we've been building on top of that since. We've recently released our AI dashcam and introduced driver-facing cameras along with driver behaviors. But being on top of AWS means that we can go and look at our legacy applications and reimagine them. We can have another go at it and release an MVP and test the water. We did that with Reveal Field. We took our workforce management platform and went back to the drawing board and tried to figure out what a new offering would look like with new technology. And so we introduced intelligent scheduling and job management with Reveal Field and fully integrated it with the Reveal experience. And so now over the last few years, this has allowed our engineering teams to focus on customer problems instead of fixing infrastructure. So, to summarize, how has this set us up for success? Well, the first is it's removed our dependency on infrastructure. We're finally focusing and getting back to being customer obsessed and looking at trying to solve their problems rather than our own. We've been able to increase our throughput by 33 times and been able to deliver and innovate at a much more rapid pace. But we've also been given the flexibility now to choose our technologies and frameworks and databases to suit our need, rather than what we had in the data center, what our teams were only able to support. And so this has meant we have an opportunity to innovate and deliver to our customers at the pace that we wanted. Thank you for listening.